Digits 1, 2, 3, 4, and 5 are arranged randomly to form a 5-digit number. No digits is repeated. Find the probability that the number is greater than 30,000. Therefore, in this case, can you see that you have 5 numbers? First part, 5 numbers 1, 2, 3, 4, 5, right? It must be more than 3,000, or it must be more than 30,000. Sorry. Therefore, it can. That means the first digit can only be 3, 4, 5. Therefore, there are 3 choices, right? And then one of them is used. One of them, no digit is being repeated. Therefore, one of them is being used. Therefore, the next digit, there is only 4 choices, and then 3 choices, 2 choices, and 1 choices. All right. And if there is no restriction, you can basically arrange these 5 digit in a the number of ways to arrange these 5 digits is actually 5 factorial. All right. Therefore, in this case, probability that the number is greater than 30,000 is actually equal to what? Is actually equal to 3 times 4 times 3 times 2 times 1. And if there's no restriction, the number of ways to arrange this 5 digit 1, 2, 3, 4, 5 is actually 5 factorial. Therefore, what you get is 72 divided by 120, and the answer is 3 over 5. All right, 3 over 5. Okay, part 2. Part 2. The last 2 digits are both even. The last 2 digits are both even. Therefore, again, 5 digit. The last 2 digit are even. There's only 2 even number here, 2 and 4. Therefore, the last digit, let's say, is got 2 choices, and then the second last digit, there's only 1 choices. All right, and then the choices for the first digit is 3, 2, and 1 accordingly. All right, and then again, when there's no restriction, the number of ways to arrange these 5 digit, the sample space 1, 2, 3, 4, 5 is actually 5 factorial. Therefore, the probability that the last 2 digits are both even, that will be just equal to what? That will be just equal to 3 times 2 times 1 times 1 times 2 divided by 5 factorial. Therefore, what you get is actually 12 over 120, and the answer is 1 over 10. All right, let's look at the third part. The third part is the number is greater than 30,000, and it is also odd. Therefore, I think in this case, we have to do case study. We have to do case study. When it is odd, right? Can you see that the 5-digit number, when it is odd, it means that the last digit must be odd, right? That means the way you place the last digit can be 1, 3, and 5. Therefore, you have to do a case study. That means let's say case number 1. Case number 1. The first digit is either 3 or 5. Then in this case, can you see that your 5-digit number, this is a 5-digit number. Okay, first digit is 3 or 5. Therefore, can you see that the last digit can be 1 or the one that is left behind. That means if the first digit is 3, then you are left behind with a 5, right? If the first digit is a 3, then you are left behind with a 5. Therefore, you have 2 choices here, right? Okay, and then now can you see that the first digit is either 3 or 5. Therefore, this one got 2 choices. And then can you see that you take care of the first digit and you take care of the last digit? Then in this case, the second digit, you have 3 choices, and then 2 choices and 1 choices. All right. Therefore, number of arrangement now is actually 2 times 3 times 2 times 1 times 2. Therefore, you get 24 cases. Then the second case, case number 2. The first digit is a 4, or the first digit is a 4. Okay, when the first digit is a 4, then can you see that? Okay, okay, can you see that first digit must be because to be greater than 30,000, the first digit must be 3, 4, 5. Therefore, I think my first case cover the case when the first digit is 3 and 5. The second case, the first digit is actually a 4. Therefore, now we look at this 5-digit number. Okay, it is a 4. I think I will use a circle to say that it is really this digit 4. All right. And then in this case, the last digit can be 1, 3, or 5. Therefore, now you have 3 choices, and then you're left with 3 digit. Therefore, this will be 3 choices, 2 choices, and 1 choices. Therefore, number of arrangement will be just equal to what? It will be 1 times 3. Take note, that means this digit 4 means 1 choice. There's only 1 choice, right? 3 times 4, 3 times 2 times 1 multiplied by 3. And in this case, that will be 18 cases, all right? Therefore, the probability that the number is greater than 30,000 and it is odd, and it is also odd, is just equal to what? 24 cases plus 18 cases divided by 5 factorial when there's no restriction. When there's no restriction, that means in this case, this would be 42. All right, 42 divided by 120. Therefore, I think you can divide by 6, or 7 divided by 20. That would be the answer. Yeah.